Today we will see some special integrals from indefinite integral. And before that, we will see some standard substitutions which will need in proving some facts. So whenever there is a root a square minus x square term is there in the integral, we will put x is equal to a sine theta or x is equal to a cos theta. As the this is because of the first fundamental entity, sine square theta plus cos square theta is equal to 1. From this identity I can get 1 minus sine square theta is equal to cos square theta, and 1 minus cos square theta is equal to sine square theta, and because of that we will use this substitution. Similarly, for root a square plus x square we will use the substitution x is equal to a tan theta. Okay, why? Because 1 plus tan square theta is equal to sec square theta, and we can take the root of that sec square theta easily. The third one is root x square minus a square. For that we will substitute x is equal to a sec theta or x is equal to a cosec theta. Both the substitutions will work for that. Root a minus x upon a plus x. So in this formula we will put x is equal to a cos 2 theta. Okay, so or there is one another way, we will multiply divide this by a minus x, multiply divided by the numerator, so that in numerator the square root from the numerator will be removed, and in denominator we will get square root of the quadratic factor, and it's how to find the integral we know. Now what are the special integrals that we are going to see in this lecture? The first one is integration of 1 upon x square plus a square dx is 1 upon a tan inverse of x by a plus c. Okay, the second one is integration of 1 upon x square minus a square dx is 1 upon 2a log of x minus a upon x plus a plus c. Then third one, integration 1 upon a square minus x square dx is 1 upon 2a log of a plus x upon a minus x plus c. Now if you see, everywhere whenever there is a log, I have written the integral in modulus. Okay, the term I have written in modulus only. So integration of 1 upon root a square minus x square, some constant square minus variable square, this integral is sine inverse of x by a plus c. Then fifth one, 1 upon root x square minus a square dx is log of modulus of x plus root x square minus a square plus c. The next one is 1 upon root x square plus a square dx is log of x plus root x square plus a square plus c. So these are the 6 very important formulae. They will cover approximately 50% of the integral. Okay, so and exam point of view also, they may be asked these the proof of these 6, one of them for 4 marks or 3 marks. Okay, now the seventh one is 1 upon x root x square minus a square. Its integral is given by 1 upon a sec inverse of x by a plus c, which is not much very important for us in solving the example or in proving some facts, but the first 6 are very important from exam point of view and to study the integrals. So let us see the proof of them by one. Now integral of 1 upon x square plus a square dx is 1 upon a tan inverse of x by a plus c. We have to prove it. So let I is equal to integration 1 upon x square plus a square dx. So what we will do? We will substitute x is equal to a tan theta. Then tan theta is equal to x by a. So theta is tan inverse of x by a. Also, the differential of the substitution dx is equal to a sec square theta d theta. Now, we put these two values in the integral. We get integration 1 upon a square tan square theta plus a square into a sec square theta d theta. From denominator, we can take a square common. Then we get a square in bracket 1 plus tan square theta. But 1 plus tan square theta is equal to sec square theta. So we get sec square theta upon a sec square theta. Here they cancel each other and we get 1 upon a integration of d theta. Its integral is theta. But what is theta? Already we have found out the value of theta. Theta is tan inverse of x by a. So the integral of the given function is integration 1 upon x square plus a square dx is 1 upon a tan inverse of x by a plus c. Now The example, if I given an example of like this integration 1 upon x square plus 5 square. So how to find the integral of this function? So for that, how to use the formula 1 upon 5 tan inverse of x by 5 plus a. Here a is 5, so we can directly use the formula to evaluate the integrals of this form. Now this is one way to prove the theorems. Okay, now I have one another way to prove the same theorem as the definition of the integral. You know better. What is the definition of the integration? The if d by dx of f of x is g of x, then we say that the integration of the g of x is f of x. So integration is an antiderivative. Okay, so we want to prove that integration of this term is equal to this. So instead of proving integration of this term is this, I will prove that a derivative of this is this. That is enough. Okay, so consider this term and its derivative. So here d by dx of 1 upon the tan inverse of x by a plus d by dx of c. Now c is a constant, a derivative is 0. So the derivative of only remain is 1 upon the tan inverse of x by a. In that also 1 upon a is a constant, so we can take outside. Then we want to find derivative of tan inverse of x by a. Its derivative is, that means tan inverse of f of x. Its derivative is 1 upon 1 plus f of x square into f dash of x. Use it. So 1 upon a, 1 upon 1 plus x square upon a square into 1 by a. Now after simplifying this, you will get 1 upon a square into 1 upon a square plus x square upon a square. So 1 upon a square and 1 upon a square will cancel to each other and you will get 1 upon x square plus a square. Okay, so the derivative of this function is 1 upon x square plus a square. That means integration of this function must be equal to 1 upon the tan inverse of x by a plus c. That's it. This is the proof of the another way of the proof. Okay, you can write any one of these two. The second one is 1 upon x square minus a square. Its integral is given by 1 upon 2 a log of modulus of x minus a upon x plus a plus c. So consider I is equal to integration 1 upon x square minus a square dx. So here I can factorize this. Actually, I have used 1 upon a square minus b square is a minus b a plus b. Okay, and after that, as these are the linear factors, I can write it, these factors as 1 upon 2a into 1 upon x minus a minus 1 upon x plus b. You can simplify it. After simplifying you get 1 upon x plus a into x minus a only. This is actually partial fraction. This is the third type of the integration, and that we are going to learn in the our coming lectures. So this is the way to write these linear factors in this format. Then take the separate integrals. You will get log of x modulus of x minus a minus log of modulus of x plus a. Then we will use the formula log of a minus log of b is equal to log of a upon b. Log of a by b, quotient rule. So 1 upon 2a log of modulus of x minus a upon x plus a plus c. So what is the integral of the given function? It is integration of 1 upon x square minus x square dx is 1 upon 2a log of modulus of x minus a upon x plus a plus c. Now example, integration of 1 upon x square minus 9 dx is equal to 1 upon 2 into 3 log of modulus of x minus 3 upon x plus 3 plus c. We can use the same formula here to evaluate certain integrals. The third one is 1 upon a square minus x square dx. Its integral is given by 1 upon 2a log of a plus x upon a minus x. Okay, now while the integrals of both the last one and this are the same, only difference is log of x minus a upon x plus a, and here is a plus x upon a minus x. Only the difference is that only. So consider again, we will factorize it 1 upon a minus x and a plus x. I can write them as 1 upon a plus x plus 1 upon a minus x. Okay, so after multiplying, if the x's will cancel to each other and we get 2a. This 2a will cancel to this 2a and we will get the same integrand. Okay, now separate the integrals. Integral of 1 upon a plus x plus integration of 1 upon a minus x. Now its integral is given by log of a plus x. Its integral is given by log of a minus x upon minus 1, because the linear expression, it is in the form of ax plus b, where the coefficient of x is -1. So we have to divide it to the integral. So you get 1 upon 2 a log of a plus x minus log of a minus x plus c. So again we will use the same property of the log of a minus log of b is log of a upon b. So this is the integral of the given expression. 1 upon x, integration of 1 upon a square minus x square dx is 1 upon 2a log of modulus of a plus x upon a minus x plus c. So 1 upon 16 minus x square dx is 1 upon 2 into 4 log of 4 plus x upon 4 minus x plus c. Now look at this next formula. The first 3 is without square root and the next 3 with the square root. So 1 upon root a square minus x square dx. So here it is in the form of root a square minus x square. So we have the standard substitution. X is equal to a sine theta. So sine theta is x upon a and theta is sine inverse of x by a. So what is dx? Then dx is a cos theta d theta. Okay, so we'll put all those things in the integrand I is equal to 1 upon root a square minus a square sin square theta into a cos theta d theta. If we take a square common from this, in bracket I will get root 1 minus sin square theta, and then this a and a will cancel to each other. We will get a I is equal to cos theta upon cos theta, because 1 minus sin square theta is cos square theta and root of cos square theta is cos theta. So they cancel each other. You get 1 theta. Its integral is theta plus c. But what is theta? Theta is sine inverse of x by a. So integration of 1 upon root a square minus x square dx is equal to sine inverse of x upon a plus c. So example, integration 1 upon root 81 minus x square dx is equal to sine inverse of x by 9 plus c with the help of this formula. Now look at the fifth one. 1 upon integration of root x square minus x square a square dx is log of, here should be modulus x plus root x square minus a square. So I is equal to 1 upon root x square minus x square dx. Put x is equal to a sec theta. So theta is sec inverse of x by a. And what is dx? Dx is a sec theta tan theta d theta. So the integral becomes, take a square common and take it outside the square root, you get a only, and in square root you will sec square theta minus 1, but it is tan square theta, and square root of these two terms will get a tan theta. So a tan theta from numerator also gets cancelled and you will get only sec theta, and the integral of sec theta is log of sec theta plus tan theta. So log of sec theta, this tan theta can be written as root tan square theta, and this tan square theta I can write it as sec square theta minus 1. So log of x by a plus x square upon a square minus 1. After simplifying you will get log of x plus root x square minus a square minus log a plus c. But this minus log a plus c I can write it as c sum. So where c is c minus log of a. So the integral is 1 upon integration of 1 upon root x square minus a square dx is log of modulus of x plus root x square minus a square plus c. And the example based on this formula is 1 upon root x square minus 16. This 16 I can write it as 4 square. So log of x plus root x square minus 16 plus c. Now this is the activity. This is an activity to you. You have to prove integration of 1 upon a square plus x square dx is log of modulus of x plus root x square plus a square x square plus c. And I am giving the substitution also, x is equal to a tan theta. Okay, just go writing this the proof of this. Okay, it is simple, no problem at all. You will not face any problem. You will able to solve this, as this is an activity. Okay, you do it on your own. The next one is integration of 1 upon x root x square minus a square dx is equal to 1 upon a sec inverse of x by a plus c. So in this we will substitute x is equal to sec a sec theta. So dx will be a sec theta tan theta and d theta. Put those values in the integration. Okay, so what will be here? Here x is a sec theta, so a square sec square theta, and into dx is a sec theta tan theta d theta. Then if from this I can take common a square, then interact in square root sec square theta minus 1 is tan square theta. So here a square tan square theta, and this sec theta will cancel to the numerator, and you will get 1 upon a integration of d theta. So its integral is 1 upon a theta. But what is theta? Theta is sec inverse of x by a. So the integral is integration of 1 upon x root x square minus x square dx is equal to 1 upon a sec inverse of x by a plus c. And the example on this formula, 1 upon x root x square minus 64 dx is 1 upon 8 sec inverse of x by 8 plus c. So this is all about the special integrals from the chapter integration. Recite all the formulae well so that you can use them in solving the examples.